All right, let's dive right into this. Welcome back to The Explainer, where we take those wildly complex tech concepts and turn them into clear, structured insights you can actually use. Today, we're unpacking something huge that just dropped from NVIDIA. I'm talking about Nemotron 3 Ultra. It's a brand new, open-weight AI model, but here's the kicker. It's built specifically for tackling complex, multi-step tasks in the background, not just chatting back and forth with you. It is a total game changer. 550 billion. Just let that number sink in for a second. That is the massive scale of the parameters we're dealing with in this new model. To put that into perspective, models of this sheer size usually require entire server farms just to wake up and process a single prompt. It's a staggering, almost unimaginable amount of artificial neural connections. So, over our time today, we're going to do a deep dive into exactly how an architecture this massive actually operates and why taming a beast of this magnitude matters so much for the future of automation. You know, for the last few years, the entire tech industry has been hyper-focused on basically building a smarter chatbot, right? Giving you a better, more accurate answer to a single question. You ask, it answers, boom, done. But NVIDIA is pushing us way past that. We're stepping into the era of the action-driven agent. We're moving from those single-turn answers to sustaining really deep reasoning across long, multi-step workflows. An action-driven agent doesn't just stop when it gives you an answer. It actually looks at that answer, decides if it needs more information, grabs an external tool to go find it, and keeps looping until your broader mission is actually accomplished. So, to make sure we don't get lost in all this dense technical architecture, here is a quick roadmap for our explainer today. We'll hit part 1, a new AI paradigm. Then, 2, inside Nemotron 3 Ultra. 3, the orchestrator workflow. And finally, 4, a reality check and limitations. Let's jump right into part 1, a new AI paradigm, beyond the chatbot. NVIDIA is making some really bold claims here. Nemotron 3 Ultra runs up to 6 times faster than comparable open models, and it cuts the cost of running complex agent workflows by roughly 30%. Now, why does a 30% cost reduction actually matter so much? Well, think about it. When you deploy an autonomous agent, it isn't just making one single API call. Behind the scenes, it might make 50 or even 100 separate calls to complete just one task. If every single one of those internal reasoning steps costs you a premium, trying to scale up an AI workforce becomes financially impossible for most companies. Cutting that overhead by a third, that completely changes the math for enterprise adoption. Moving right along to section 2, inside Nemotron 3 Ultra, under the hood. Okay, so the secret sauce really starts right here, with something called a mixture of experts, or MOE design. Basically, this is an architecture that activates only specific parameters for a given task. It's kind of like a massive corporation with hundreds of specialized departments. If you have a question about a new marketing campaign, you don't drag every single employee from accounting, HR, and IT into the boardroom, right? That would be incredibly slow and ridiculously expensive. Instead, you just call in the 5 marketing specialists who actually know that specific topic. That is literally what's happening inside this model. Every time it processes a request, a routing mechanism steps in and directs the prompt to the exact cluster of neural networks trained to handle it. And because of that mixture of experts design, we arrive at this crucial number, 55 billion. Remember that 550 billion total we were just talking about? Well, only about 55 billion of those parameters are active at any given moment. This stark contrast is exactly why a model of this colossal size can still run incredibly fast and relatively cheap. It's only using the specific brainpower it strictly needs. By keeping 90% of the model powered down for any given word it generates, it dramatically saves on server costs, slashes latency, and lowers power consumption. It takes an otherwise impossibly heavy model and makes it highly deployable. Architecturally, Nemotron 3 Ultra is rocking a hybrid design. It weaves together Mamba layers, which are highly efficient for maintaining long context, with your traditional attention layers. Usually, with pure attention models, the computational cost literally explodes when you feed them too much text. Every new word has to be mathematically compared to every previous word. It gets exponentially harder. But the Mamba blocks prevent that computational explosion. They act more like a highly efficient conveyor belt, compressing information as it goes. This allows the system to handle up to 1 million tokens of input without breaking a sweat, all while keeping the really sharp reasoning capabilities of the attention layers totally intact. Now, combine that with multi-token prediction. Instead of laboriously guessing just one word at a time, which, by the way, is how most traditional large language models function, this model drafts multiple future tokens in a single pass. It acts as a massive built-in generation speed boost. Imagine typing an email and having your software not just auto-complete the next word, but predict the next 3 or 4 words simultaneously. That is exactly what's happening down at the silicon level, making navigating that massive 1 million token context window incredibly snappy. But honestly, the true headline here might just be the openness. NVIDIA isn't just dropping the model weights, handing us a mysterious black box and calling it a day. No way. They are releasing the open training data, the post-training recipes, and the reinforcement learning environments used to build it. This is a massive, massive deal for developers. Usually, the exact data and training methods are closely guarded corporate secrets. By releasing the reinforcement learning environments, NVIDIA is basically empowering developers everywhere to deeply inspect, fine-tune, and deploy this model on their own infrastructure. You get to fully understand the exact mechanics going on inside the engine.
All right, Section 3, let's shift gears to the orchestrator workflow, theory to practice.
So the absolutely crucial point here is how this model is optimally utilized. It's an orchestrator. It acts as the central brain sitting at the very top of a workflow, coordinating other tools and smaller models beneath it. You don't just ask it a question, you give it a mission to manage. It might send a coding task to a smaller 8 billion parameter coding model, or ask a web scraper tool to pull data from a website. The orchestrator doesn't do all the heavy lifting itself, it acts as the project manager, making sure all the subordinate tools are working together efficiently. Let's walk through a concrete example of this 5-step workflow in action. Imagine you ask it to write a comprehensive market research report on the electric vehicle industry. Step 1 is research and synthesis, where you feed it broad prompts to digest vast amounts of data across the internet. Step 2 is planning and breakdown. The orchestrator figures out dependencies, like realizing, hey, I need battery cost data before I can project future sales. Step 3 is delegation. It actually hands specialized subtasks off to other tools, like a search API. Now, step 4, and this is a huge leap forward, is verification. It actually reviews the returning outputs against the original plan. If its subordinate tool brings back bad data, the orchestrator catches it, rejects it, and reruns the task. This catches errors that older AI workflows skipped entirely. And finally, step 5 is compilation into a polished final document. Or consider this alternative workflow, long document analysis. Because of that million-token context window we talked about, you can literally drop an entire book, a massive code base, or a giant dataset into a single prompt. To put 1 million tokens into perspective, that's roughly the equivalent of loading 15 average-sized novels into the system's working memory all at once. It effortlessly cross-references information across hundreds of pages, allowing you to ask highly targeted, complex questions about the document as a whole, without the model forgetting what happened back in Chapter 1. Let's move to Section 4. Time for a reality check and limitations. Grounding the hype. Look, it's really easy to get swept up in the excitement, but let's slow down and look at the practical constraints of actually deploying this technology today. Here are the 3 main limitations you absolutely need to understand. First, hardware constraints. 550 billion parameters means you need multiple high-end enterprise GPUs. Think racks of expensive silicon, just to load it. You'll likely access this through an API or a hosted platform, not your local laptop. Second, benchmark realities. The 6x speed and 30% cost cuts are from highly specific tests. Your real-world mileage will absolutely vary by use case. And third, open does not mean easy. Building these multi-agent systems requires complex engineering, strict error handling, and deep tool integration to ensure it doesn't get stuck in some endless loop. Zooming out to the macro level for a second, the competition isn't just about who has the smartest chatbot anymore. It's about who can build models that reliably operate over time, across many steps, with minimal supervision. Figuring out how to verify these systems while they work independently is the entire AI field's next huge hurdle. Because if we want AI to book our flights, manage our calendars, and execute research independently, we desperately need models that can supervise themselves. So the real shift here is a design philosophy focused on verifiable, long-running work built in the open. The flashy parameter numbers and speed benchmarks are definitely impressive, for sure, but this fundamental shift in how we design and use AI to orchestrate multi-step workflows matters significantly more. We are moving from simple assistants to autonomous managers. So I'll leave you with this final provocative question. What's the very first multi-step task you'd hand off to it?
If you had a model coordinating your entire workflow, where would you start? That wraps up our explainer for today. If you enjoyed this focused breakdown, like, share, and subscribe, please, and drop a comment in comment box.